Welcome to the video lecture series on theory of computation, and today's lecture we will be learning about how to convert a DFA to regular expression using state elimination method. And this is a popular method. So DFA to regular expression can be done with the help of state elimination method, and another method is called as add-on method. So in this lecture we will be learning about state elimination method in an elaborate fashion. So the theorem is actually, for instance, we have a state called as Q1 and Q2 and Q3, where the predecessor state is actually Q1 and the successor state is Q3. That means from Q1 to Q3 you are supposed to make a transition, and Q2 is actually acting as an intermediate state here. And if you have a direct edge from Q1 to Q3, we call it as Rij. Okay, and from if you have a edge from predecessor state to intermediate state, that is from Q1 to Q2, we call it as Qi. And if you have any kind of self loop in an intermediate state, we just make it as S here. And if we have any kind of transition from intermediate state to the successor state, that is from Q2 to Q3, we just make it as Pi. Okay, so now if this is the form, and I want to eliminate all the intermediate states, in this case actually Q2 is called as an intermediate state. To eliminate intermediate state Q2, I have to take all possible combinations, all possible transitions, which includes Q2. Okay, and finally, while considering all possible transitions, you should you apply this formula Rij plus Qi. S star is called a self loop for the intermediate state, whereas Pi, and you have to apply this formula and solve the problem. And as for the step number 1 is concerned, when you are using state elimination method, except the initial state and final state, none of the states should exist. That means all intermediate states except the initial state and final state should get eliminated. And while eliminating, you have to consider all possible combinations, and you have to put it in the form of Rij to Qi S star Pi form. Convert into that formula. Now step number 2, suppose if you have Qi, that is initial state and final state, are actually distinct states, if both are not identical and if both are not equivalent. In that case, we just make the state as a two-state automation, and if that is the form, if Qi is called as initial state and Qf is called as final state, and we have a set of transitions like this, R is making a self loop in initial state and U is making a self loop in final state, and initial state to final state we have a transition S, and from final state to initial state we have a transition called as T. So if this is the form, then you just convert that into a respective theorem like this, put the formula like this: R plus Su star T to the power of star, whereas Su star. Okay, so this is nothing but the theorem, and this will be demonstrated with the help of, illustrated with the help of a problem. Now this is the step number 2 here, and suppose now I have a state, step number 3. In this case, that if you have a start state and accepting state, both are not same. Okay, both are same. For example, if start state and accepting state are same, then you are considering a one state automation. In this case, Q0 is considered as initial state as well as final state, and it makes a self loop called as R. Okay, so you can make a regular expression simply as R star if this is the case. And finally, you should derive a regular expression using a reduced format by using the rules of rule number 2 and rule number 3, what we have discussed now so far. Okay, so this is nothing but the rule number 4. Now the problem here is we will apply the theorem what we have learned so far. Now I have to convert the problem DFA to regular expression, and this is the problem. So Q1, Q2, Q3, whereas Q2 is going to act as an intermediate state in this case. Okay, so Q1 is initial state and Q3 is called as a final state. Now what we are going to do here is we will just consider all possible combinations. So what is all possible combinations? So I want to eliminate Q2 is called as an intermediate state, and if the intermediate state has to be eliminated, I should take Q2 into consideration, all possible considerations. So I take case number 1. So what is case number 1? So case 1. Okay. So if I use case number 1, the first initial state is actually Q1. Okay. From Q1 to Q2 intermediate state, from Q2 to Q3. Okay. So in this case, Q1 is called as an initial state, that is called as a predecessor state, and Q3 is called as a successor state. Okay. Now we will just do one thing. We will convert this into a equivalent diagram. Now Q1 is called as a predecessor state and Q3 is called as a successor state. Now when you just go to the theorem, what is Rij here? So what is Rij? Rij is actually if you have a direct edge from the predecessor state to successor state, that is called as Rij. Okay. So now we will just consider what is meant by Rij here. Rij, if you have any edge from Q1 to Q3. So in this diagram, so there is not any edge from Q1 to Q3. There is not Q1, there is an edge from Q1 to Q3, direct edge is there. So Rij, so there is a direct edge from Q1 to Q3 and the Rij value is actually 0. Okay. Now, what is the next thing? Now see here, I just take up this diagram. So if I have edge from the predecessor state to intermediate states, that is called as Qi. Okay. So predecessor state is Q1 and intermediate state is Q2. If I have an edge here, then that is considered as Qi here. So we will just check it out whether predecessor and successor is having any edge here. So in this case, predecessor is Q1 and intermediate is Q2. Whether there is any edge from Q1 to Q2, yes, Q1 to Q2 there is an edge and that is transition is Y. So Q of I is equal to 1 here. Now the third one, whether there is S star. Okay, that means if intermediate star node is having any kind of self-loop transition, that is considered as S. Now what is intermediate node in this case? Intermediate node in this case is actually Q2 is called as intermediate node, and whether there is any self-loop for Q2, yes, self-loop for Q2 is there, that is called as 1. Okay, so S is equal to 1. Okay, and finally from intermediate node, do you have any kind of transition to the successor node? So Q2 is called as intermediate node and Q3 is called as successor node. If there is a edge transition from Q2 to Q3, then that is called as Pi. So we will check it in this diagram. So what is the intermediate node here? In this case, intermediate node is Q2 and successor node is Q3. So from Q2 to Q3, any transition exists or not? From Q2 to Q3, there is a transition that is called as 0 here. So we will make Pi is equal to 0. Now thus put into a respective formula. So when you put it into the respective formula, the formula is Rij plus, then you should write Qi, S star, then Pi. Okay, so now just apply all the respective values. Rij is 0, Rij is 0, Qi is 1, and S is 1 here, so written as 1 star, and Pi is 0. So okay, now putting together, so this is the regular expression for transition from Q1 to Q3. Now I'll write case 2. We'll just write case 2 here. So case 2. So what is case 2? Now I take a predecessor node as Q1 and successor node as Q3. Now I take a successor node as Q1 and predecessor node as Q3. Intermediate node I should always consider as Q2 because that is the node which we want to eliminate. So Q1. So now in this case Q3 is called as a predecessor node and Q1 is called a successor node. Now I want to know have Rij. So what is Rij? Is there any edge from the predecessor node to successor node from Q3 to Q1? Is there any edge? Now see here, from Q3 to Q1, obviously there is not any edge from Q3 to Q1 here. So Rij is equal to pi. Listen to the pi. Okay. So next is I want to have Qi. So what is Qi? If there is edge from transition from the predecessor node called as Q3 to intermediate node called as Q2, if there is any edge here. So predecessor node is actually Q3. So Q3 to Q2 I have a transition called as 1. So Qi is 1. Okay, Qi is 1. Now the third thing what we have to come here is next is yes. So now yes is actually, is there any self loop for intermediate node called as Q2 here? Intermediate node is Q2. So yes, we have a self loop for Q2, that is 1. So I can write yes equal to 1. And finally, is there any edge from intermediate node Q2 to the successor node called as Q1? Okay, and that has to be denoted by Pi. So Pi is equal to, so is there any edge from Q2 to Q1? So Q2 to Q1, there is not any edge here. So just make it as pi. So I just make it as pi here. Now putting this into a respective formula, you will get pi, Rij is pi, then Qi is 1, S star is 1 star, and Pi is pi. Okay, so anything actually multiplied by pi, you will always get the answer called as pi. 1 into 1 star into pi, you will always get pi. So the answer is pi is the final answer in this case. Okay, so in this case it is pi is the final answer. Now I have identified two states here. Now we will just put together case 3. So what is case 3 here? So case 3, now Q3, Q2, Q1 has been taken into account. Now we will take next possibility is, so Q1 is the predecessor state, Q2 is an intermediate state, and again Q1 is the successor state. So it is returning back to Q1 itself. Now this is another case. If this is the case, so Rij, so whether there is any edge from Q1 to Q1. Okay, so predecessor to successor, that is Q1 is predecessor and successor is also Q1. Is there any edge from Q1 to Q1? So in this diagram, actually Q1 to Q1 there is not any edge here. So Rij is pi. So Rij is pi. Okay, so next is Qi. Qi means from the predecessor node called as Q1 to Q2, as there is any edge here. Okay, now in Qi, Q1 to Q2, there is an edge called as 1 here. So there is an edge called as 1. So transition 1 is there. So Qi is 1. And the next is S. So S is considered as Q2 is considered as a self loop here. So S is 1 here. So I just make S is equal to 1. And finally, now from Q2 to Q1, whether there is any edge here. So that has to be taken into as Pi here. Okay. So Q2 to Q1, whether there is any edge here. So Q2 to Q1, so no edge is there for from Q2 to Q1. So again, just make it as Pi is pi. So Pi is pi. Okay, now put this into a respective formula. The formula is Rij, that is written as pi, and Qi is 1, and S is 1 star, and Pi is pi. So since you are multiplying with pi, so answer is always pi here. Okay. Now this has been taken into account now. So case 3 cases I have completed. Now we will go for the fourth case. So case 4. So what is case 4 here? So I will take Q3 to Q2 and Q3. So this is the last combination here. So Q3, Q2 and Q3. Okay, predecessor and successor are Q3. Intermediate is Q2. And what is the Rij? Rij, is there any edge from Q3 to Q3? Yes, there is a edge from Q3 to Q3, that is called as 0. So Rij is 0. Now I will take the value called as Qi. Qi, what is Qi here? So Q3 to Q2, whether there is any edge here. So Q3 to Q2, there is an edge here, that is called as 1. So Qi is 1. Okay. So next is yes, whether there is a self loop in intermediate node called as Q2. Yes, there is a self loop. Okay, Q2 1. So yes is equal to 1 here, and last one is Pi. So Pi. So what is Pi here? So from intermediate node Q2 to Q3, whether there is any edge, any transition takes place. Yes, from Q2 to Q3 there is a transition, and that transition is called as 0. So Pi is 0. Okay, now put it to the respective formula. So when you put it to the respective formula, Rij is plus 0 and Qi is 1 and S is 1 star and Pi is 0. Okay, so now this is the regular expression. Okay, now we have to put this calculations into the respective diagrammatical representation. So I have Q1, Q2 and Q3 states here. In this, Q2 has to be get eliminated. So I have the remaining states are Q1 and Q3. So I will draw this diagram. Q1 and Q3. Okay. Now let us see what is the transition here. So in case 1, we travel from Q1 to Q3. Okay, from Q1 to Q3. So what is the regular expression? From Q1 to Q3, the regular expression is 0 plus 1 star 0. Okay, so from Q1 to Q3, I just make it as 0 plus 1 star 0. Okay. Now coming to case 2, Q3 to Q1. Okay, Q3 to Q1 I have pi transition, so no need to include that. And again from Q1 to Q1. Okay, so again I have a transition called as pi, no need to include that. Now come to case 4, Q3 to Q3. So okay, Q3 to Q3 you have a expression called as 0 plus 1 star 0. Okay, so this is the concept here. So Q3 to Q3 I should write 0 plus 1 star 0. Okay, so this is the regular expression. Now if you take up this, actually I have two sets of states, one is initial state and another is final state. Now this does not attain a form like this, isn't it? So when you just see the diagram, even though there is two states here, it does not take a form. You don't have any backage from final state to initial state. Okay, so since no backage is there is no need to apply this one. For this formula need not be applied here. So what to do with this case? Now you can put it together. This is called as a self loop here, self loop. Okay, and this is a regular expression like this. What you have to do is just put it together. Now you can just take this self loop away. So how to take this self loop away? You can just use Q1 and use Q3. Okay, eliminate that self loop. That self loop is actually whatever which is going to repeat it. The 0, 1 star 0 is going to get repeated. So here you have 0 plus 1 star 0. This is one regular expression, and another is going to get repeated. This one is going to get repeated. So I use 0 plus 1 star 0 whole star. Okay, whole star means it can be repeated any number of times. So the regular expression, what you derive from this is R equal to regular expression 0 plus 1 1 0 star 0 plus, and then 0 plus 1 1 star 0 whole star. Okay, so this is the regular expression, equivalent regular expression for the set problem, given problem here. Okay, so that's about regular expression from a DFA to regular expression conversion. So thanks for watching the video. Have a good day.